Hi, Algebra 2 students. Today we are going to start Chapter 13. We are going to review some right triangle trig. Some of it you learned in geometry, some of it's going to be a little bit new. So we're going to start by taking a look at a right triangle and an acute angle theta right here, and the relationship between the side opposite, adjacent, and hypotenuse. Now what I know you know from geometry already is SOHCAHTOA. The sine of theta is the opposite side over the hypotenuse. The cosine of theta is the adjacent side, so the side that's touching the angle over the hypotenuse. And that tangent of theta is opposite over hypotenuse. But what I think is new is the three reciprocal trig identities below. Okay, the CSC is said cosecant. So the cosecant of theta is hypotenuse over opposite. So if you know sine of theta, you also know cosecant because it's just the reciprocal of sine. SEC is said secant. So the secant of theta is the hypotenuse over the adjacent. And same thing, if you know cosine, you know secant. It is just the reciprocal. And finally, COT is said cotangent. Cotangent is the reciprocal of tangent, so adjacent over opposite. Okay, let's look at an example. So in this problem it says evaluate the 6 trig functions of the angle theta. Well, before we can do this, we need to make sure that we have all of our sides and that we know which side is opposite, adjacent, and the hypotenuse. So back to geometry, when we want to find the missing side of a right triangle, we can use the Pythagorean theorem. So my hypotenuse would be a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared, and so 169 equals c squared, and then we would square root to get 13 as c. So our missing side is c. Now before we identify our 6 trig functions, let's label these. So if this is my angle theta, imagine this is my eyeball, so looking across here at the 12, this would be my side opposite. Remember that the side touching the angle is always the adjacent. And then the hypotenuse is always opposite the right angle. So this is our hypotenuse. Oops, sorry about that. Okay, so when it says evaluate the 6 trig functions, that means we need sine of theta, cosine of theta, tangent of theta, we need cosecant of theta, secant of theta, and cotangent of theta. And again, from the first slide, that if you know the first 3, the next 3 are just the reciprocal. So the sine of theta is opposite over hypotenuse, so 12 over 13. Cosine is adjacent over hypotenuse, so 5 over 13. And tangent is opposite over adjacent, so 12 over 5. Cosecant, okay, well if sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And then cotangent is adjacent, so 5 over opposite, 12. Easy enough, just a little bit new stuff to the things you already knew. The next thing we're going to review is our special right triangles. So we have a 45, 45, 90 triangle. So with a 45, 45, 90, remember that these angles are the same. Means these side lengths are the same, and then we have our hypotenuse. the relationship between the hypotenuse and the side length, that the hypotenuse is the side length times the square root of 2, and that the side length is the hypotenuse divided by root 2. So always, instead of just memorizing here, think about it this way. The side length is becoming longer. So if you want to make something longer to go from here to here, we are multiplying by root 2. Okay. Well, to go from the hypotenuse to the side length, we're making something smaller. So to go this way, we're dividing by root 2. Okay, our other special triangle we have is a 30, 60, 90. Notice that I already have them labeled as L, S, and H. S stands for the short side. Remember that the short side is always opposite the 30-degree angle. L for the long side. The long side is always opposite the 60-degree angle. And then H for hypotenuse. Again, always opposite the right angle. So our relationship is this. If we start with the side length S, which is opposite the 30-degree angle, the hypotenuse is twice that length. So the hypotenuse is 2 times the short side. The long side is the short side times root 3. So remember, you're making the short side longer if you're going to the long side. So multiply that by root 3. And you can really start in any direction. Okay, if you start with the hypotenuse. To get the short side, we divide by 2. To go from there to the long side, we multiply by root 3. So let's do a little bit of practice and we'll see how we're doing. Okay, so in these examples we are going to find x and y. So if I take a look here at this first one and I notice this is a special right triangle, notice that it doesn't say it's a special right triangle, but I know it is because this angle is 30, which makes this angle 60, which means I have the hypotenuse. The side opposite the short side, this would be S. The side opposite the 60 would be L. So to get the short side, it would be the hypotenuse divided by 2, which is 9. So that makes y equal to 9. To go from the short side to the long side, remember that the long side is root 3 times S. So the long side is root 3 times 9. So x equals 9 root 3. Check out number 2. Again, another special triangle. Because I gave you this is 60, that makes this 30. Okay, well, what do I have? I have the side opposite the 60-degree angle, so this is the long side. This is the short side. And this is the hypotenuse. So I'm starting with L. I know L is 4. Well, in my previous slide I said that L equals root 3 times S. So to go to the other way, I need to divide both sides by root 3. And I would say L over root 3 is S. Well, I know what L is, so I have 4 over root 3 equals S. In this case is x, the short side. Remember to rationalize your denominator. Multiply top and bottom by root 3 gives me 4 root 3 over 3 as x. Okay, so I found x. Now to find y. Y, remember, is twice the length of the short side. So y is pretty easy. Y would just be 2 times 4 root 3 over 3, which would be 8 root 3 over 3. Okay, coming down here, I've got a 45, 45, 90. This is kind of cut off down here, but that does say 45. That means this one is 45. To go from the side length to the hypotenuse, y would just be 7 root 2. Down here is the x. It's kind of cut off in the video. Okay, remember that these two side lengths of a 45, 45, 90 are the same. So x equals 7. Okay. Over here for my x and y, notice that x and y are going to be the same because it's 45, 45, 90. Okay, and I'm making something smaller. So I'm going to divide both sides by root 2. So x would be 12 over root 2, which again I'm going to rationalize. Multiply top and bottom by root 2. So I get x equals 12 root 2 over 2, which equals 6 root 2. So both x and y are 6 root 2. Oops. Okay, so here I have some video examples for you to try. The first one of identifying all 6 trig functions, so sine, cosine, tangent, cosecant, secant, and cotangent, and then finding x and y of my special triangles. This is a y down here, kind of cut off. Alright guys, thanks for watching my video. We'll finish this lesson up in class.